Hi guys, I am Chekwa and I am back with Maths XYZ, and today we will be continuing still on identities on trigonometry. This is the lesson that we have been doing for the past from the past 4 lessons, and we will continue to do more examples on how to answer questions on identities. Alright, identities we have 2, which is sine squared theta plus cos squared theta is equals to 1. Please take note that the identity says plus cos squared theta. If it's a minus, then it's not an identity. Then the second one is tan theta. It's equals to sine theta divided by cos theta. Alright, these are the identities that we will be looking at when we are answering the questions, our questions. Then the first question says, the question that we're going to be doing on this lesson, it's a proof question that we must prove that the left hand side is equals to the right hand side. When you are dealing with questions on proof, you can choose either to prove from the right hand side or to prove from the left hand side. But please take note that you can only work on one side at a time. If you can't prove from the left hand side, then you should stop and then start from the right hand side and see if you can get to the final answer. All right. The first question says that we must prove that 1 plus tan squared theta multiplied by cos squared theta, okay, it's equals to 1. So this is the left hand side and that's the right hand side. Then we are going to be proving from the left hand side. You must always notify that you are proving either from the right hand side or from the left hand side, so that the marker who will be marking your paper can know which side to focus at. Then from now we are looking only at the left hand side of the equation. Then from here, to have 1 plus tan squared theta all into brackets multiplied by cos squared theta. This cos squared theta will be multiplying into the brackets. Then we'll have equals to cos squared theta plus cos squared theta tan squared theta, right? Alright, from here we have to change cos. We have to change tan, into we have to change tan according to this identity, which says that tan theta is equals to sine theta divided by cos theta. Then we will have sine squared theta, divided by cos squared theta. Alright, from here we can already see that this cos, the 2 cos will cancel out and we'll only be left with cos squared theta plus sine squared theta. Alright, cos squared theta plus sine squared theta, what is it? It is an identity which says that sine squared theta plus cos squared theta is equals to 1. Then from here, we can, even if it's like this, even if it doesn't start with a sine squared, it still is the same as that one. Then it is equals to 1. Then it is proven that our left hand side is equals to the right hand side. Then the question, it is true indeed that the left hand side is equals to the right hand side. You must always write at the end of your answer that therefore it is the left hand side is equals to the right hand side, so that you can notify that you got the right answer. All right, let's look at another example. It's the same this example on proof that the left hand side is equals to the right hand side. I'll just make space there. Right, the question that we're going to be doing, it says sine squared theta plus sine theta plus sine theta cos theta divided by tan theta. It's equals to 1. Then we're still proving that the question is equals to 1. Then from here, what we can do is to take the common factor of sine theta from the numerator, but we can't do that because we have a fraction there. So the first thing that we must do is to remove the fraction and make it a one big fraction. Then we'll have tan theta, sine squared theta plus sine theta cos theta is equals to tan theta. Remember guys to always write that you are answering from the left hand side. Then from here we can now take a common factor of sine theta, of which we'll have sine theta into tan theta plus we have sine theta cos theta here because the sine theta is squared. Sine theta plus cos theta. Right, then divide by tan theta. Alright, from here now, remember tan theta, we can change it to be sine theta divided by cos theta. But looking at them that they won't cancel out, let's first look at the tan theta. Then tan theta, to change it, it's equals to sine theta divided by cos theta. Alright, then we'll have sine theta divided by 1 in the numerator, multiplied by cos theta divided by sine theta. Alright, then we'll have in the brackets tan theta sine theta plus cos theta. Alright, those will cancel out and we'll be left with cos theta into the brackets. When it's multiplying into the brackets, let me just multiply clear. We'll have sine theta cos theta tan theta plus cos squared theta. Alright, from here we can now change tan to be sine theta divided by cos theta. Tan is equals to, let me write with a different color mark. We'll have tan is equals to sine theta divided by cos theta. Alright, and then sine theta divided by cos theta, the cos theta will cancel out with this one here, it will cancel out with that one there, and we'll be left with only sine theta multiplied by sine theta, which would be sine squared theta, plus our cos squared theta, which is on the other side of the sine. Now we are left with sine squared theta plus cos squared theta, and we know that this is an identity which is equals to 1. Then therefore our left hand side is equals to our right hand side. It is proven that the left hand side is equals to the right hand side, because the right hand side is equals to 1, and we also got 1 after simplifying the left hand side. Alright, let's do a question, the third question on identities. Alright, the third question says that we must prove that tan squared theta divided by 1 plus tan squared theta is equals to sine squared theta. Alright, now we are proving from the left hand side of the equation. Then from here we change the tan and the tan there. Then we'll have sine squared theta divided by cos squared theta divide by 1 plus tan theta is actually sine squared theta divided by cos squared theta as well. Then we have a fraction in the denominator. To solve out for the fraction, we'll have sine squared theta divided by cos squared theta, all divided by this multiplied by that, we'll have cos squared theta plus sine squared theta divided by cos squared theta. Alright, and then from here we can actually see that cos squared theta plus sine squared theta is equals to 1. That means that in the we are now left with sine squared theta divided by cos squared theta, multiplying it will be cos squared theta, and then cos squared theta plus sine squared theta is equals to 1. That means that we'll have to divide by 1. Then this and this will cancel out, and we'll only be left with sine squared theta. We'll only be left with sine squared theta. Do you guys see that we have sine squared, our right hand side, it is equals to our left hand side. Then it's proven that our left hand side is equals to the left hand side. Then guys, if you are dealing with identities, always know, before you can approach any question, write your identities down. And after that, when you're approaching a question, always look back into what the notes that you have written, that an identity of time is equals to sine divided by cos, and identity identity of sine squared plus cos squared is equals to 1. Then when you're dealing with that, you can always look back and see if there's an identity, change it according to the rule, and then see how you can manipulate your equation. Like for this one from here, you can just see we don't have to go even further with the cos squared theta plus sine squared theta, because we know that it's an identity which is equals to 1. Then from there you can just make it 1, and then already that means that cos will be left on its own, and where after cancelling each other, you will only be left with sine squared theta, which does prove that the left hand side is equals to the right hand side. All right, let's do another example, the last example, and we'll see how to answer questions on identities. All right, this one says that we must prove that 2 cos squared theta plus 5 cos theta is 5 minus 3 divided by 2 sine theta cos theta minus sine theta. We must prove that this is equals to cos theta plus 3 divided by sine theta. Alright, we're taking it from the left hand side. This is the right hand side. It's just that we didn't have space to write on the right hand side of the board. Then looking at the first expression, which is on the left hand side, we have 2 cos squared theta plus 5 cos theta minus 3, and in the denominator we have 2 sine theta cos theta minus sine theta. We can already see that in the denominator we will have to take out the common factor of sine theta, and we'll be left with 2 cos theta minus 1 inside the brackets. Then in the numerator, the 2 cos squared theta plus cos theta minus 3, we have to factorize it so that it can cancel out with the denominator. Then let's let x is equals to cos theta and y is equals to sine theta. Alright, then we have in the denominator we have numerator, we have 2x squared plus 5x minus 3 divided by 2xy minus 1. Then in the numerator, factorizing out, we'll have 2x and x and 3 and 1, of which this will be plus and this will be minus. And in the denominator, we'll take up the common factor and we'll be left with 2x minus 1. This and this will cancel out, and we'll only be left with x plus 3 divided by 1. Alright, we'll be left with x plus 3 divided by 1. Remember, our x is equals to cos theta and our y is equals to sine theta. Then that means that we have cos theta plus 3 divided by our sine theta. Alright, now it is indeed that the left hand side is equals to the right hand side, because it's equals to the cos theta plus 3 divided by sine theta. It's equals to the left hand side, the simplified equation of the left hand side. I hope you guys enjoyed our lesson, and if you have any question, please put it on the comment note, or just send us an email at mathsxyz@gmail.com and we'll have a follow-up on it. And don't forget to subscribe to MathsXYZ so that you can get daily notification when we upload videos. Thank you.